Hello, everyone, and welcome to another Directions Mag Geospatial webinar, today sponsored by our friends over at Laser Technologies. I'm Barbara Duke, Editor-in-Chief here at Directions Mag, joined by our webinar producer, Lynette Qualia. We encourage you to read the latest geospatial news, articles, listen to podcasts, of course, catch more webinars over at directionsmag.com. We are excited to have Derek Rash back with us today. He is going to tell us about the latest things happening over at LaserTech and improving those workflows for everyone out in the field. So, Derek, welcome. We're glad to have you back with us today.
Well, thanks a lot. I appreciate it. Appreciate Directions Magazine. And Barbara, thanks so much for the introduction. Yeah, I'm Derek Rash with LaserTech. I'm the Senior Product Manager. And I focus on the Professional Measurement Division, which kind of relates to anything that anybody has to measure or collect data in the field in GIS, forestry, construction, electric utilities, you name it. We try to get our solutions in that area with everything. So glad to be here and talking about some of our solutions we've got today. Probably several of you on the call here do know about LaserTech, but the others that do not. LaserTech, we have been in business over 35 years. The same two guys that started the company are there today. We are just outside of Denver, Colorado, where we design, manufacture, and distribute laser rangefinders, sensors, and laser enforcement products, all out to here side Denver, Colorado with the manufacturing. So we got a service center. We have service centers all across the world. We have one in Ireland and in Asia. Also, our biggest thing is patents. We got to make sure we protect ourselves with what we develop and design with all these different products we've got. And we work through a dealer network across the world. So if there's something interesting here with our products that you're interested in, you can reach out to one of our partners across the world, and they can also combine things together with our products with other GNSS receivers solutions that we're talking about today. So the webinar today just talking about what LaserGIS is and the workflow. It's a term we've been using for several years now about just collecting data in the field. We're going to talk about how the best way to collect for best accuracies and then all different mapping methods that we have, utilizing the offset laser mapping methods with integrating with GNSS devices and what accuracies you're going to get out of that. So we'll talk about that, and we've got a couple white papers and blogs and handouts that we talked about earlier that you can download. And we're also going to just talk about laser integration with different apps that you might have or want to check out. First off, what is a laser rangefinder? I think a lot of people think when we say rangefinders, they think the sports optics, which we were involved in with the sports optics also. But ours are when we do it in the professional measurement world, we kind of we crank up the power in a way, the accuracy I'll say. So that's our laser sensor. It's a pulse sensor. Does not need to have a reflector to capture the distance. So as long as you have a clear line of sight, you're able to get a distance to almost any object, that value. And then in all our lasers, we have an accelerometer to measure tilt. So it's just the angle of the units to give you the degree of tilt, negative and positive. You can see there to the right diagram. And then other lasers, we put in the compass sensor. That compass sensor does where we're able to measure azimuth or bearing direction. And it has no tilt or roll limitations. So you can maybe see that gyroscope kind of rolling around there. So there's no tilt or roll limitations, and we maintain that azimuth accuracy. We also do modular systems, modular sensors, the angle sensor. I will talk about where we're able to calculate the horizontal angles. A compass can be affected by magnetic interferences, and when that comes into play, we suggest having an angle sensor, and I'll talk about this product here shortly, to measure that horizontal angle so you can get still those 3D measurements. What does that look like? Here's a couple diagrams I use all the time, and that's just talking about what's that look like to you, these different measurements. So our laser is SD, or what we call slope distance. It's also referred to as line of sight. So you can see that there. And then our tilt is inclination, degree of inclination, INC. And then the compass is AZ for azimuth. With the press of the fire button, all those sensors will measure, get a value, and then the unit will automatically calculate a VD or vertical distance and an HD horizontal distance. And you can see those being calculated right there. And at that same time, everything downloads to, if you're connected to an app, it automatically downloads via serial port or also Bluetooth. And we'll talk about that here shortly in some other slides. Not only just taking measurements, we want to have some onboard routines. So a lot of people want to capture heights or clearances. So we built in a 3-point height shot, what we call it. And so you see up in the upper left, you take a shot 1 to the object, get that measurement, and then you do a base angle or top angle and a base angle. And then the unit will, the laser will automatically calculate a height measurement for you based on all those values. And again, that outputs very quickly to the app that you're connected to. So you can repeat that. You can do multi heights with this shot, this routine, but it's an easy one to do height measurements or clearances. Another one we call is missing line. This is where we put in the compass, and you can get the span between 2 remote objects. So 2 shots, stand in a safe location, take the measurements, and then it calculates all those different values. So it acts like you're standing at that one pole to the left and taking the shot to the right. And then we also can do slope measurements, the diagram on the right-hand side, and also the length of that. So there's a lot of different values, onboard routines, not just taking measurements and getting distances, but we have onboard routines that you might want to add to any of your data collection processes. So this is the model, TruePulse 200X model, going through the ones we've got. The 200X, you see the range accuracies, plus or minus about 1.5 inches in the range. And you can see the range distances there and inclination. So this is a 2D laser, measures the slope distance and also inclination. So these are the values you're able to get to it, and then it does that auto calculation I've talked about earlier. So that's the 200X. It's our most accurate laser rangefinder we've got. And so you can see there just different specifications on the 200X model. When we incorporate the compass sensor in the unit, we call that the TruePulse 360R model. Different accuracies here. In the range accuracy, you can see is about 8 inches. The big thing you want to look at is the azimuth accuracy. I mentioned about that no limit to pitch and roll. So we maintain a 0.5 degree accuracy of azimuth, which is you'll see that here in a few slides about when we talk about the position accuracies of what that really does mean. So you can see there again, everything's measured. Everything in red is measured up in the right-hand diagram, and then the VD and HD are calculated automatically with the press of the fire button. And you're able to capture distance and all these values like within 1/3 of a second. So it's very quick. It's not long. You don't have to wait too long to get these measurements, as long as you got a clear line of sight to the objects. When we in the horizontal, the true angle, actually this is where the unit will calculate or measure horizontal angles. So this is a modular system. We integrate it with our TruePulse 200X, a laser, and the true angle. So you're still able to get 3D measurements. You still get your slope distance, inclination, and now a turned angle. This is where it's not affected by magnetic interferences, where a compass might. Good for roadways, construction zones, etc., to still be able to get all these different measurements. And you see that different accuracies we get with the true angle itself and the true angle. So this is kind of more of a modular system. If you already have a TruePulse 200X, you can incorporate a true angle and have a complete solution. So I think everybody knows about collecting data in the field, just about the different workflows that we've got that you use. And we're talking mainly right now about just working with the GNS or GNSS devices and GPS devices. We've used this slide a few other times, but mainly, I think everybody knows when you're doing that, you're walking up to a feature, doing your set, make sure you got all your settings correctly, start capturing that position, capture everything you need to, all your assets, everything you need to at that point, attributes, and then make sure it's really good, and then you walk to the next feature and you repeat the steps. So kind of walking around in different areas of what's needed and capturing those different positions. But I believe a lot of you guys, and I've even run into it myself, working with people about just different challenges you run into. I think we've all seen these before. I think I was just at the Esri IMGIS show this last week, and guys were asking me about how do I capture a manhole that might be underneath a vehicle. How can I get that asset? How can I do that remote location? So those are different ways of how am I going to get that? So it could be also dangerous, busy streets, you got to close the street, etc. That turns into being expensive. Other challenges, just different canopies, urban canopies, tree canopies, just getting those signals. Now the signals are getting better and better, but there's times that you just need that's going to be a troublesome area. My biggest one is private property, or so I always call it the Doberman effect. I'm not going to cross that area and go into where there might be a dog or anything like that to capture a position I need. So those are different things for challenges. Another big one is, again, when you do have to walk up to every feature, stuff like that, there's multiple features, you're moving around a lot. So that's another part is another challenge is you got to move to every feature that you've got to capture. So it could be, just time consuming, etc. So that's where things are different challenges that you run into. And then there's always the safety factor that I see, again, with the roadways. Right now, probably a lot of people are working by themselves out in the field. And so you don't know what's going on, or you're in trenches, etc. So the big thing is about safety factor that you got to look at are different things you kind of run into in challenges. How now the lasers are to maybe help out that time consuming workflow, collecting data in the field. Instead of walking up to every spot, well, we call this laser offset mapping. So this is, again, you occupy a position, and I'm going to go back to that safety factor all the time. Just, again, you might be working by yourself or next to the roadway or anything like that. Get in a safe location, get that position. And now with the laser you've got, and also the GIS app or data collection app, which I'll talk about, you take a measurement with the laser, you get these values that I discussed, the distance, the tilt, the azimuth or an angle. And with all those different values, the app will take those values with the known location and calculate that remote position. So you can stand in one location there and just take multiple shots. Again, this is how you can quickly capture data from one position. So that we call that laser mapping. There's different workflows too. And so talking about the different workflows, utilizing different lasers. You might be able to use different lasers for the workflow or whatever is best for your application too. The main one, the easiest way to position objects is what we call Range-Azimuth. That's using our True Pulse that has a compass built in, and it's with a simple workflow here. You stand in one location, you get your position, your GNSS position. Once you got that, you measure, again, those are the laser values to the target, and that app, again, uses the current location, all the values the laser gives you, and calculates that remote point. So you can stand there quickly and measure a bunch of assets or features from one location and capture that. So it's commonly used for forest mapping, like I call it street furniture, capturing all that in parks and things of that nature, and sign inventory, or where there's a lot of features that are densely populated. They're right there. You can stand in one location and kind of shoot all different directions and capture what you need to. It's fast, quick, easy to move around, easy to traverse. So that's a pretty quick way to do that. The biggest thing you have to take into account is what I call magnetic hygiene. It's just paying attention to magnetic interferences. If there's pipeline, or if you're in a heavy construction zone, etc., that might affect the compass accuracy, which will affect your position accuracy, your remote position accuracy. So those are things you got to take into account as you're looking at how you're going to collect data in the field with utilizing laser rangefinders. Another one we've got, another workflow that's incorporated in a lot of different apps, is called the range, or sometimes called distance. This is a very accurate way to do this. And all you need is just a true pulse 200X model. And so we're just giving it a range and tilt with this. The workflow is it's got more of a two-step workflow. So you stand at a point, get that GNSS position, and then you measure to the target. You measure the distance and inclination to target. And from there, the app kind of walks you through which way you go left or right of the target, get a new position, take a new distance measurement, and then the app will calculate that remote coordinate based on all those values. One thing I've got a tech tip here. This is a big one. It's kind of like when you do move to your second control point, you kind of want to make sure everything's like an equal triangle. I mean, I know it might not be as easy in certain areas. That's why you've got to look at the area that you're measuring. Might be less features that you need it a little bit more spread out. But you just want to make sure you do that good geometry. So that one position, you move to the second position, just making sure that's kind of all equal to measuring to the object. If you're too close, if that's too close of a triangle, your position accuracy will not really calculate out correctly. So you got to worry about that. So that's those things you've got to kind of, what's your tolerances, what's needed best for what you need to do to collect that asset. But this is another workflow where you're, again, safety, standing on the side of the road, or if there's a canopy like this tree down below, that you're able to stand out in a clear line of sight and be able to still capture that remote position. The last mapping method we've got is where we're going to use range angle. That's using the TruePulse 200X and that true angle. This is more like a total station workflow. So we're using precise angle measurements. So it's more of you set up a position, grab that GNSS position, then you're going to move to a new location, and then you backsite basically back to that first position you're at. So you're zeroing the true angle on a known position. The app knows everything, calculates this, and then from that new control point, you're able to take a measurement to the object, and again, the app calculates everything, calculates that remote position based on all those values. So it can be used for high density features again. It's not affected by magnetic interferences. Again, that magnetic hygiene used in a compass. Once you're at that new control point, you're able to take multiple measurements from that spot. So that's, from that area. If you have to move, there are different ways to move. You can traverse to a new location, and then you're just going to shoot back to that last position you're at. So again, it's like that total station workflow, but a modular system that's very easy to use, and the workflow is pretty simple with the way we've got everything set up. A question that always pops up every time we talk about this: what is my position accuracy? We've done a lot of testing on this about different workflows, different lasers, and different distances. So you can see here, just this chart. I'm not going to go through each one of them, but this is a big question we get all the time about what is going to be my position accuracy and what fits into your tolerance budget. What's needed for you guys? What's needed for the job? So you can see here different ways and what you're going to get when you're taking these different workflows, different lasers and true angle, and different distances. In the handout we've got a white paper on this, talking a little more in depth about this. So if you want to take a look at that, again, it's got more information detailed about our workflows and our study on of capturing all this information. Also in those handouts, we've got is kind of a little more blog information about those workflows I just talked about, those 3 different workflows. There's a little more detail about it. I kind of ran through that pretty quick, but it just gives you more information and depth of that. So if you want to take a look at those other handouts that we've got here, if you have questions on that. So another big thing is like, okay, so I understand the workflow. It's great. I've got lasers. I've got a GNS device, but what's the data collection? What's the GIS app? So what's good for you guys, or what you might have? So this is I'm going to go through these. I'm not going in detail of each one of them. We have a lot of quick reference guides on our website that go into more detail about how the laser interacts with these different apps I'm going to talk about here. And so I'm just going to go through each one of them kind of quickly. But if you want more information, again, we've got those quick reference guides that you can do a deeper dive. So if you have these apps have a laser interface built in. There are a lot of other ones out there in the market. It seems like every time I go to a trade show, I'll run into somebody that wrote an app with our laser for their specific application all across the world. I'm naming a few here. But we also have a list again on our website about other apps and even software programs that have a laser interface. It's we do make apps too. Something I forgot to mention at the beginning. We also do software development or app development for Android and iOS. And this one we've got here for kind of more of the GIS mapping is what we call LaserSoft MapSmart. We design it, of course, very laser-based. So you fully utilize our laser and all our different mapping methods that I talked about. So laser mapping, you can start with a GPS location. We did incorporate GPS. You can use an external receiver, etc. In this. You can start off with that, or you can just start off an origin of 000 and then start mapping from that spot. So that's a good way it's a really simple, user-friendly app to capture data, capture points. You can also just use GPS mapping, stand-in plot as calling it, and then also just a combo of that Range-Azimuth laser offset method. This app is, this one's on Android that we've got here, but it's very simple to use. And again, all those different workflows are developed in this MapSmart program. We partnered up with Leica back in 2020. They made their Xeno mobile app, and they incorporated a few different workflows, mapping methods with our laser rangefinders. So you can see the different mapping methods here. They call it horizontal, distance, and azimuth. That's that one kind of a one shot again, offset, the distance. And a new one they put in is azimuth. So if you cannot get a range to the target, or just a certain area where there might be an obstacle in front of it, but you know the direction of that tree, will say, they have a different method here is azimuth. It's in one of our white papers, or blogs. I mean, if you want to learn a little bit more about that, they have that method in their system or their app for the Xeno mobile. You see the requirements below, Android, and which lasers we have that interface with their app there. A business partner of ours, Trimble, we've been working with them for a number of years. Their TerraFlex app, they've worked in a different type of workflow, an adaptive offset method. Kind of adapts to your user, your project, the environment. One thing I do like about this workflow is if your tolerance, the app will know which laser you're using, knows the accuracy of the laser, and then if your offset, the offset position is not within your tolerance, it might say, hey, you need to take an additional shot. It might go from range azimuth, then say, hey, you need to do range to get to your fit into your tolerance needs for that offset position accuracy. So it's a pretty easy wizard to walk through. Just quick setups of the offset measurements. They've got the two different workflows, single shot they call it, and the two shot. And then you can see the requirements. It's all on different operating systems that our lasers work with. So it's a really easy workflow. Again, what I like about it, it kind of pays attention to your position offset accuracy and says, hey, it gives you an error code and lets you change things as needed on the fly. And so again, in all these different apps we've got here, the one I'm talking about, we have more detailed presentations and quick reference guides for this too. When we worked with EOS, another business partner of ours, and the first ones to develop a laser offset workflow fully within field maps is EOS positioning. You can see here they've incorporated all different mapping workflows in there, and you see the range, all different ways we can get our lasers working, all with iOS. So it's a companion app, really easy to use. It's all within that workflow of field maps. It goes out to the companion app of Tools Pro. You run through the process. It's real simple to walk through. I mean, you can see all the different screenshots there and what you're looking at. Walk you through, you submit, and it goes right back into field maps. So you're not even jumping in and out of it. It's really easy to do. And they have all the different mapping methods that we talked about earlier. So all of our lasers work with iOS. They've got a bridge system so some of our lasers don't work with iOS. They've got a way to work with those lasers into that work or into those different operating systems. Very simple way to work. Again, one of the first ones to do this with field maps. So it's an easy way to get that offset position that's needed. Another company we've worked with, Bad Elf, they incorporated a laser workflow also within field maps. It came out this last year. They use their Bad Elf Flex and their Flex app. You can see down the requirements. They've got two different mapping methods that I talked about. You see there the different workflows. One thing they've done is they've added height measurements. I talked about that height routine early on about onboard solutions. Now they've got it where you can capture height of that remote position. If if it's a light pole or a tree or anything that you need to capture the height, they've got a method of doing that, capturing that attribute of that offset position also. So kind of a quick keeps it all in that same workflow here. You can see there, just kind of just runs through the different steps, almost walking through there to capture distances and offsets and heights. A new one we've been working with this last year, they talked about it here at the Esri UC this last year. It's about integrating the laser into Survey 123. So been working with that team. It's a form-based data collection, and so they've incorporated our laser kind of under the hood. It's in the beta version right now with the rangefinder add-in, and they've got several different workflows. They're doing the offset only, which is just the Range-Azimuth offset. The height measurement I talked about earlier, capturing that, and multi-height. We're working through this multi-height measurement, so you can capture, like on a utility pole, you can capture a lot of different assets on that utility pole. They've got a way to do that, of capturing this different workflow. And the last one over there to the right, they got height and offset. So these are different workflows that is in their beta version we're going through. If you're interested in this, to take a look at it, please reach out to myself or get onto the Survey 123 beta test team, or get on that area, and you're able to look at this add-in and do this workflow. So we've been working with these guys over this last all summer here about adding the laser interface, like under the hood in Survey 123. Other apps I've mentioned before. There's so many different apps out there. Can't even count them. But here's a couple other ones that we've worked with over the past. ProStar PointMan. You can see there they've got laser interface built in that, and also CartaPack up on Fort Collins here. They've got a laser interface built in, and more details, our quick reference guides, more details on this, but I just want to talk about there are other available apps that kind of fit into different markets. Like CartaPack is very in the oil and gas area, water, and so those are ones that are out there. And so these are different apps that have a laser interface. There's a lot of other ones that are on the marketplace. Too many to mention right now, but you might already have some of these apps, and then you incorporate a laser to increase increase that time in the field or capture data that's needed. So it's time consuming. You can do that quickly with the different workflows we've got and our different laser rangefinders and applications we've got. I mean, there's so many different applications. It's great to hear, especially the wild ones that I've heard. I like the baseball field one down here. They actually mapped out the fence line of AT&T Park. I know it's not AT&T Park anymore, but they were out there mapping that. So that's great. Of course, I'm a baseball guy, so that's one of my really good story of using our lasers there. But you can see these different applications, and again, there's a number of them. People always talk about, well, I need to do this or map, like I said, manholes underneath a vehicle, or I can't occupy that point. So those are the big things that are there. And I always go back to that safety factor of different applications. So these are just a list of a few that always pop up that we talk about. So these are good ones to look at. And again, sure, if you can see it and you can measure to it, we can do an offset to that location if it fits into your tolerance for your offset tolerances. Just to wrap it up. Again, I appreciate everybody's time today. One is just our tagline: measure more, move less. So talked about time consuming, and I harp on the safe location. Every time I've gone to a few different electric utility companies, and you always set through safety classes first before you start doing anything. It's all about safety right now. Again, I don't think anybody really sees those orange shirts out there, orange vests anymore. So these are good things to think about. It can be efficient, and if it fits into your tolerances, and maintain that precision accuracy with the different mapping methods, different lasers, accuracies, etc. And then the last one, save time and money in that workforce out there. So you've got different ways of just kind of seeing how a laser fits into your workflow. That's basically what we wanted to talk about, and there's a lot of different apps to work with, and to see how you can save time and money utilizing our laser rangefinders and different devices to collect the data. So if you have any questions or anything like that, one, please use the chat. If I can't get to those today, or if some of them come in later, you can always follow up with LaserTech, send it to the info. Usually that gets to me and a few other tech support guys, are people that will be able to answer those questions. And just with all that, and I wanted to thank Directions Magazine for having us today. Appreciate it. These webinars are fun to talk about our solutions, especially around this time.
Wonderful. So let's try and squeak in a couple of questions here for you, Derek. I know that you mentioned all those apps, but someone had a question about the devices themselves. So iOS, Google. I mean, what sort of devices is this cross-platform sort of scenarios with those apps?
Right. Yeah, we get that question a lot. So the TruePulse 200X is the laser that works with iOS devices. So you can have the TruePulse 200X that's got a Bluetooth that's MFI approved with Apple. So it is able to work with that. So even utilizing the 200X and the True Angle, you're still able to use going into iOS devices. All the other lasers I've got, the TruePulse 360 and the other models we have had over the years are Android or Windows based. There are a couple of ways that the EOS positioning bridge product. Mm-hmm. That is a way to actually take one of our what we call classic Bluetooth modules or lasers and go into iOS. So it's an external device that they're able to go into iOS. That's a different way of getting in there, which is pretty cool. But directly from ours is the TruePulse 200X. That's a good question.
Great. And I see one more here that is, where can they get more information on the various app workflows? So maybe somewhere over at lasertech.com specific, where should we start looking?
Yeah, I'd start with those handouts that we've got there, those blogs that kind of talks about the different workflows of the mapping workflows and the app workflows. If you go to our website and professional measurement portion of that, and then we've got technical documents, and that kind of, you can drill down to that, and that's going to go into the specific app that you can get a presentation or a quick reference guide of how we connect the laser, how you set it up in that particular app and everything like that. So we've got a pretty good quick reference guides on our website.
Okay, great. Well, we're almost out of time here. Just want to remind everyone, if you've got another burning question, jot down that email address, info@lasertech.com. Derek, thanks again for being with us. We appreciate you sharing your expertise. Always great to have you come hang out with us. We hope that everyone goes and makes it a great day. Tell a friend about Laser Tech and Directions Magazine. Thanks, everybody.